Hello and welcome to Semaphore Uncut, a podcast for developers about building great products. Today I am excited to welcome Eric Bowman. Eric, thank you so much for joining us.
Hey, thanks, Darko. It's great to be here.
Great. Please just go ahead and introduce yourself.
Yeah, so I'm Eric Bowman. I'm the CTO of TomTom, which is a location technology company based in Amsterdam. I live in Berlin, and I've been here for about 7 years. I was previously at Zalando and Gilt Group, and 3 in the UK. A long time ago, I worked at Maxis computer game company. You know, CI/CD has in particular been quite an interesting topic in my career, so I'm really thrilled to join the podcast.
Great. Thank you. You mentioned that you became CTO of TomTom recently, although you have spent quite some part of your career at TomTom. Maybe you can give us a brief overview of how that progressed for you and how you ended up being CTO.
Sure. Yeah, I joined TomTom originally in 2007 as a software engineer. And, you know, TomTom historically has had kind of its biggest success making sat-nav devices and was sort of a kind of an embedded software company. And I came to work on some of the early online efforts, including a map-based route planner. And I really fell in love with the domain of location technology, this kind of perfect fusion of data and algorithms and kind of real world outcomes and really having an impact on how people get around and, you know, how the world can kind of run more efficiently and cleaner. I was living in Ireland at the time with my family, and we had a new baby. And in 2011, the kind of commuting between Dublin and Amsterdam became problematic, and I ended up leaving TomTom. And I joined Gilt Group, which was an e-commerce company based in New York with an office in Dublin. And I also, at that point, got into engineering management and stayed with Gilt for several years, and then ended up moving to Zalando in Berlin, which is also an e-commerce company based in Berlin. And really, you know, got to experience quite a growth cycle with Zalando and led a pretty significant transformation inside the company. But I always had kind of a soft spot for location technology, and I stayed in touch with TomTom. And when the time was right, I came back just over 2 years ago and led engineering more in the online services world. And then on July 1st, became the CTO, which was, for me, I think, quite a long time aspiration. So I'm really excited about the new role.
Congrats on that. Yeah. You seem to be really passionate about technology, but at some point in your career, you moved slightly more towards, you know, leadership and management. Can you maybe give us a brief overview how that worked out for you? And yeah.
Sure. Originally, I wanted to be a physicist, and writing software was something that I did on the side, you know, somewhat as a hobby, in part to sort of supplement the work I did in physics and in part to make money on the side. And life in physics is kind of hard. It's really hard to have the kind of impact that I really wanted to have in the world. Ultimately, you know, I wasn't smart enough to have that kind of impact. And I just enjoyed software so much. But one of the things about studying physics is that you really come to appreciate a certain kind of beauty. And the expression of physical law through mathematics has a compactness and an elegance that is, you know, really profound, especially as you get deep into it. And for me, that was very influential kind of in my personal life and my intrinsic motivation. And I saw similar kind of beauty and symmetry in software and, you know, loved building systems that worked. But for a long time, I was very, very motivated purely by the technology. And ultimately, I think part of my kind of journey to more holistic role in the technology industry, getting into management and also understanding the commercial side, was starting to understand that it's more than just the technology, it's how the technology fits into the bigger system of the world. And really understanding, you know, that everything, for example, stems from customers, and that, you know, really focusing on what customers really need and what's valuable to them, what are they willing to pay for or contribute to, and then organizing, you know, through kind of organizational structure and architecture and supporting infrastructure to create essentially value streams that still manifest the same beauty that really triggered me earlier in my career, was just a tremendous challenge and a really exciting one.
We've just released the CI/CD for Monorepos ebook. It's for software engineers who are evaluating or want to optimize the monorepo way of software development. You'll learn how to build a monorepo-first CI/CD pipeline and have a functional microservice application built, tested, and deployed from a monorepo. Check it out on our website, semaphoreci.com/resources/monorepo-CICD.
And you talked about your first days and physics and then software being on the side and mapping technologies and generally what the world really looks like and how much do you diverge with your mapping technologies and so on and all those challenges. Can you maybe talk about this domain? Because I think that the majority of our listeners at one point in their life saw a TomTom device somewhere on the shelf if they haven't owned it. But maybe they are not so familiar with the whole technology behind mapping and TomTom in general.
Sure. When I joined TomTom in 2007, it had experienced exponential growth by more or less, defining the category of sat-nav device. And they changed how people drive kind of forever. In fact, one of the co-founders and the current CEO, Harold Godin, was recently inducted into the Automotive Industry Hall of Fame because of the impact that he and TomTom have had on drivers. And it's sometimes hard for me to remember what life was like before smartphones. And it's also hard for me to imagine and remember what life was like before good in-car satellite-based navigation. I remember printing out maps from MapQuest and driving around and getting frustrated. It's one of those things that people really take for granted without understanding everything that goes into it. TomTom was a big customer of a map company called TeleAtlas. And one of the things that really excited me initially at TomTom was when I began to understand that they were building this feedback loop, which I later came to realize is commonly called a flywheel, where they were putting SIM cards into sat-nav devices in order to collect anonymous probe data, which allowed them to build a real-time model of traffic conditions globally. For many people at the time, there was the first time their TomTom suggested, taking an exit off the motorway to avoid a traffic jam. And it's kind of one of these miracle moments where you kind of can't believe that technology could do that. And then you very quickly get angry if it doesn't do it perfectly. And this idea that by selling more devices, they got a better traffic model, which led to a better product, which would sell more devices, just a powerful, powerful flywheel mechanism. And I didn't know the term flywheel at the time, but I could understand the dynamics. And it was like, wow, this is really, really smart. And now, we know that what we were doing, although the term hadn't really been invented yet, was implementing an Internet of Things. And in purchasing TeleAtlas, although, it turned out the world economic conditions made that a little bit painful at the time, but it opened up the opportunity to use an Internet of Things to then essentially much more cheaply and much more accurately build a map using computation. And that feedback loop, essentially, yet another form of flywheel, was much more powerful. But for a variety of reasons, that has taken longer than we hoped. Introduction of Google Maps, for example, was a significant challenge. And in some ways, I think the technology was not ready yet. I think it's difficult for people to have an intuitive understanding of the complexity around map creation and just the scale of the problem. And even though the data itself is not necessarily that big in kind of like big data terms, the interrelatedness of the graph and the dependencies within that are really, really complicated. And, when you make changes to the map, it's extremely difficult to make sure that you don't introduce changes which cause unintended consequences elsewhere in the map. It's a computationally very hard problem. But for me, the kind of dream of just building a better and better representation of reality, using not necessarily fewer people to do so, but increasingly advanced technology, which essentially, raises the level of what humans contribute to the map, continually higher, is really thrilling. And I think, especially when we look toward a much more autonomous driving-based future, the importance of doing this and doing this in a way where people's privacy is respected is really, really important.
As you were talking about this, in physics, you want to describe the world by equations. And in mapping technology, you describe the world through maps. There is a connection there. And as you have been talking about maps and the feedback loop, I mean, from our side, when we are joining calls with our customers and potential customers, I mean, the main thing that we talk about is a feedback loop. It's a feedback loop for developers as they are developing their software and they want to know, as fast as possible, ideally under 5 minutes, if there is anything, that the test have caught. And then they can, keep their flow of, thought and continue working on that and not wait for a long time to get the results overall. So the speed of a feedback loop is essential. You mentioned that there are quite a few challenges with running general tests and CI CD process around like maps. Can you give us a glimpse of what are some of the challenges?
Yeah, so when you're trying to represent reality, the only way to really test it is against reality. And when you're talking about the whole planet, that's a difficult proposition. You can't go out and visit all these different places. And so we have to be much smarter about how we do that. And, there are some nice trends in the world which make that easier. There's a lot of data now flowing from cars. We've been collecting different forms of that data for a long time. And it's really, really messy data, but in aggregate, it becomes pretty precise. But simply understanding, is the map correct is a totally non-trivial problem, let alone, is this address correct? And is the entry point into the parking lot to go to this particular address correct? And each one of these problems on its own is sort of an interesting problem to solve. The problem is that there's tens of thousands of those problems. And it's both, in terms of intellectual work, extremely challenging. And then the compute requirements are also pretty significant to do that at scale, but also fast enough for it to be valuable in the cases where it's kind of most valuable. So, if anybody who bought a car over the past decade or so, in-car navigation is pretty common, but it's also pretty common. The map is very quickly out of date and difficult to update. In some cases you have to get a CD-ROM and figure out how to plug that into your car or take your car in and have someone update that. But when you look at really modern transportation problems, if you take a ride-sharing service, for example. So I had this experience in Berlin recently. I would normally walk to a kind of standing appointment. It was a 35-minute walk and I was running late. And so I jumped in a rideshare. And Friedrichstrasse in Berlin, a very famous street, was recently converted into a pedestrian-only street. And the routing software, navigation software, wasn't updated to reflect that. And this poor fellow had to drive around and around trying to find some way to get me where I was going. And it ended up, it would have been faster to walk at the end of the day. And of course, it didn't cost me any more, but it certainly cost the ride-sharing company more. And it was a moment of reflection of at scale with hundreds or thousands or tens of thousands or even more vehicles that have inaccurate maps, it introduces significant inefficiency for people and for companies. As we get used to the convenience factor that technology affords, we know when things are going to be delivered, we know when we're going to arrive. It starts to affect all the things around us in our daily lives. And when one part of that starts to break down, it has these knock-on effects. If it were the past and everybody knew that no one knows how long it's going to take and whatever, the overall system was resilient. As we take advantages of more convenience, we also lose some resilience. And so, the importance of when a street is closed, that's got to be known by, thousands, tens of thousands, hundreds of thousands of people very, very quickly. And then you look at all of the processing power required to make sure that those changes are actually real and reflect reality. It's a massive computational problem, and it's completely feedback based. And I think, as you mentioned, and kind of the miracle of DevOps and the role of CI/CD, but also really any modern product development, whether it's in location technology or anything, it's all about feedback. And, people so often, they think of value flowing one direction, but the reality is that to do anything interesting, value has to flow both directions, kind of all the time. Any place in technology now where you're not getting feedback, it's a missed opportunity. I think, TomTom, we have that at a bigger scale than most companies, but the same principle applies everywhere.
We've just released the CI/CD for MonoRepo's ebook. It's for software engineers who are evaluating or want to optimize the monorepo way of software development. You'll learn how to build a monorepo-first CI/CD pipeline and have a functional microservice application built, tested, and deployed from a monorepo. Check it out on our website, semaphoreci.com/resources/monorepo-CICD.
Speaking further about TomTom and what you do, so you also mentioned that actually majority of her business is now B2B, although the brand is more known from B2C segment, it's B2B now. Can you maybe talk a bit about that?
Yeah. So, when we acquired TeleAtlas was in the business of selling what we call uncompiled maps. Different companies buy a map database and then build technology on top of that. And that's actually a pretty big business. It's not particularly well known that happens, but lots of companies, insurance companies, for example, do that. Other navigation companies would buy our map. I mentioned the kind of live traffic model. We sell that to various different companies, including automotive companies. We sell our navigation software to run in cars. We sell our map to run in cars. We're increasingly moving toward a much more online offering that can compete with Google Maps, for example, by providing good search, good navigation, good map, good display, and enabling people to get around, but also solving the harder problems of kind of massively parallel routing problems, something called matrix routing, for example, where if you have 1,000 rideshare vehicles and 1,000 customers trying to get a rideshare vehicle, how do you do that most efficiently, for example? Ultimately, all of that ends up being bigger than our consumer business at this point.
Maybe to move for a second in the realm of like mainstream media, maybe you're a very competent person to comment on the self-driving future, maybe hype at some points. What are your thoughts on that as someone from the inside?
Not surprisingly, it's taking longer than people hoped, but maybe not really longer than many people expected. And I think it ties a little bit into a comment I made earlier. Our intuition is not very good at understanding what is the true complexity of the world. And when it comes to the map, it's a relatively static world. Obviously the world's constantly changing, but we're in a map, we're trying to capture static snapshots. And when you throw in the complexity of then trying to move dynamically through that ever-changing world, it's computationally, extremely hard. But I think, innovation is kind of unstoppable. It's happening slightly different than we expected. I certainly remember the first time I got into a car that could partially drive itself and I didn't quite understand what it was doing. Instantly, almost seconds, I figured it out. Okay, yeah, this is helpful. Now I want more, and now I want more. There's just so much demand for this to happen, but it is extraordinarily expensive to figure out how to do it. The mistakes, cost lives, and the amount of compute required in the car. And then, there are fundamental disagreements about how is it best going to work. For example, we make something called an HD map. Our traditional map is sort of human understandable. An HD map is more optimized for use by software. And, it's essentially providing yet another input to an autonomous driving engine over just what it can see, through a camera or through LiDAR. Not everybody even agrees if HD maps are necessary. And, it's expensive to create an HD map, and even things like what's the right resolution is undecided. So it's one of these kind of like unstoppable forces meeting immovable object situations, but it clearly has such an opportunity to profoundly change how we live and ultimately to give us much more control as a civilization over, very important things like emission levels. It's got to happen, and it is happening, but it's at least another decade of innovation before it feels like the future we were promised.
Yeah. Sounds reasonable. 10 years is not that long.
No.
And as you were describing that this is, such a hard problem and computationally intensive. I mean, also, if I would contrast that to what's our day-to-day work. So we work with a very, almost 100% of deterministic software, and solutions and all that. And the domain that you were talking about, mapping in general, and now this self-driving is maybe to some extent continuation of that. What do you see how a day-to-day work of a software engineer maybe have changed? You mentioned that you joined TomTom in 2007. Now, like almost 15 years later, how a role of a software engineer has changed at TomTom?
Well, even, not just at TomTom, but everywhere. I think in 2007, I remember being very frustrated by a situation which I think was pretty accurately reflected in the Phoenix project. And, it just seemed like it couldn't be the way to do it, but we weren't smart enough in one go to figure out how it should be done. Before I was at TomTom, I was working for the company 3 in the UK, which is a telco and a highly regulated environment. It was pretty hard to ship software in that environment because the consequences for failure were terrible. And our understanding of how to build resilience was pretty limited. And, cloud didn't exist yet. I was actually pretty late reading the Phoenix project. It was recommended to me right when it was published, and I was like, yeah, I'll get to that. I started it once and was like, yeah, we're past that already. Don't care. Then I did finally go back and read it. It's like, okay, actually, this is pretty important. And it also led me to read The Goal, which is also something that I wish that I had read much, much earlier in my life. I think my life might have taken a different path if I had read The Goal when I was a young person, because The Goal, it's not a story about a factory. It's a story about physics, and it's a story about software and the importance of global optimization and how very hard that is. And, nowadays, I think working software engineers, everybody is sort of comfortable with the idea of DevOps, for example, but I think not enough people understand the intellectual history behind it, which I think is really necessary to make the really hard decisions. When I was at Zalando, I ignored DevOps while we were simultaneously reinventing it, and we could have been learning from it, but we all thought DevOps was just like, software engineers and operations teams being one, and we'd already been doing that for a while, and that was kind of obvious and whatever. But now, the importance of working software engineers to just the compounding of value that can occur through constant small iterations. So you mentioned, a second ago, 10 years is not that long, which reminded me of Gates' law, which you probably know, which is, I think people tend to overestimate what they can do in a year and underestimate what they can do in 10. And that's because humans think linearly almost always. And anything where we're compounding value is exponential. And the profound power of the ideas behind DevOps and CI/CD and, the accelerate KPIs is really about how do we get into a situation where we're compounding value at scale faster and faster. And in a way, I feel really lucky to have been part of the journey that basically has transformed software development in my lifetime. But at the same time, there's actually not that much awareness of everything that went into it, and the thinking behind it. There's been so much energy spent and, arguably wasted talking about agile methodologies. Parts of that are really important, but it's absolutely local optimization. The compounding in value comes from global optimization, which is from thinking about value streams, connecting people to customers, and managing dependencies carefully. And none of that has anything to do with most of the agile methodologies, with possible exception of Kanban. But even Kanban tends to lead to a lot of local optimization. And so what software engineers today have the opportunity to understand better is how they connect to customer value. It used to be much, much harder. I mean, when I started, software was shipped on a CD, and that was considered modern. And it's like, whatever happened when it landed on some PC somewhere was somebody else's problem. And, through ingenuity, we did great things, but my God, we could have gone so much faster. if we had figured out a little bit sooner, like the second the internet was born, to create the feedback loops that basically enable a compounding effect. So that's one part. I think the other part is the role of machine learning in modern software development. Some people called it software 2.0. I think that was a little bit overstated. And ultimately, it comes down to getting really comfortable with data engineering, which is a necessary component of anything involving feedback. The tools now are just so incredible for that. The billions and billions and billions invested over the past decade by some of the biggest companies in the world. Those investments have opened up value to everyone. That's certainly one of the key things that I would encourage anybody kind of sharpening their skills as a software developer to really focus on.
As majority of developers are working with, let's say deterministic software, and the results that the software creates are, easily testable and understandable, should everyone and will everyone in the future needs to tap into that part of like neural networks and so on of machine learning where the results are not 0 and 1.
Yeah. So I wouldn't over-index on determinism. It's great when you can have it, and you should seek it everywhere you can, for sure. For example, I wouldn't be a huge fan of continuous stream processing. It's way better to think of it as very small, discrete changes. It's a massive simplifier, and it can become deterministic. But when software meets the real world, you lose that determinism. And so on the one hand, you want to hold on to it as long as you can and leverage it everywhere you can, but also be prepared for the fact that once it hits the wild, determinism is kind of gone, right? And not be surprised by that. And so that's one reason why I'm not a big fan of staging environments, for example, and believe very strongly in finding a safe way for people to develop in production. Even though you lose determinism, but you find out really quickly when things work and when they don't work.
Okay, great. It was a very interesting conversation. I love the overview of what DevOps is and how you see it. Good luck with your new role and all the best. Thank you.
Thanks, Darkos. Real pleasure. And thanks, everyone, for listening.